We're looking at 4.3 algebraic analysis on the vertex. Our first method is we're going to get it in vertex form by completing the square. So this right here is in vertex form. It's very easy to find where the vertex is. So we are going to change this from vertex form to standard form by multiplying it out. So if I have x plus 3 squared, that equals minus 8. That equals x plus 3 times x plus 3 minus 8. So x times x is x squared. X times 3 is plus 3x. And then we do our inside is another plus 3x. And 3 plus 3 is 9. And then minus 8. Now this is really important, this piece right here. If you notice, this 9 right here is 3 squared. And then we have 3x and 3x make 6x. So x squared plus 6x plus 9 is what you get when you times out x plus 3 times x plus 3. This is a perfect square. Okay, so when I have my x squared plus 6x plus 9, I'm going to minus 8, and then this function is going to be f of x equals x squared plus 6x plus 1. And this is in standard form. Now, when it's in vertex form, you can easily see what the vertex is. It's saying that the parabola is going left 3 and down 8. So in vertex form, we can easily see what the vertex is, but in standard form, it's not as obvious. We can't see what that vertex is. So everything in math has its opposites, and we have to be able to get back to what we started with. So first we learned to add, then we learned to subtract. Those undo each other. Squares and square roots undo each other. Times and divide undo each other. We took this and times it out to get here. We have to be able to take this and go backwards here. Now, so what I needed to do is first I need to make a perfect square from these numbers here. What I'm going to do is I'm going to take my x squared plus 6x and just look at those numbers there. And I need to add a number to make this a perfect square. I need to get to this piece here. Now, how do I do that? Number one is I'm going to take my 6x and I'm going to cut it in half. So we had 3x and 3x, and so this 3 is going to be half of the 6, because when they're going to be exactly the same, we cut it in half, we get 3. So when I put this as a perfect square, I'm going to have x plus 3 squared. So it's always half of whatever this number is. Now, when I times out x plus 3 times x plus 3, I need to have a 9 here. Okay, now I can't just add 9 to one side of the equation. I have to do this, I have to add 9 to the other side to make this work. So I'm going to have f of x plus 9 on this side. And then I have my plus 1 is left, okay? Now I want to get this in vertex form. I want the y all alone. So I'm going to minus 9 from both sides of the equal sign. And I end up with f of x equals x plus 3 squared, and 1 minus 9 is negative 8. And then I have it in the vertex form here. So these are exactly the same. But one, we went from vertex form to standard form, and one, we went from standard form to vertex form. Okay, let's look at number 3. First of all, I need to complete the square. I have f of x equals, and I have x squared minus 8x plus, I need another number to have a perfect square, and then I just move my 7 over. Okay, first thing we do is we need to make it a perfect square, and when we do that, it's kind of like here where we had the 6x I have to split it in half to get these two numbers. So right here I have a -8. I cut that in half. I get x minus 4 squared. Now if I square out my x minus 4 times x minus 4, the last numbers here, 3 times 3 is going to give me this number here. So if I take -4 times -4, that is going to give me a positive 16. Now I can't just add 16 to one side. I have to add 16 to the other side as well. So it's even. 16 plus, and then I have my plus 7. So now the last step is I want to get f of x all alone. I'm going to minus 16 to both sides, and I'll get f of x equals x minus 4 squared, and 7 minus 16 is -9. And so on both number 2 and number 3, we can find the vertex. We kind of already did 2. We take the opposite of what's ever in the parentheses, -3, and it's down 8, so -8. On number 3, we have a -4 here. We switch the signs to a +4 and a -9 here. Okay, number 4 is actually a harder problem. And the reason it's harder is because we have an odd number as our middle number here. But it still works the same way. We're going to take our x and our -5 and cut it in half. So I have -5 over 2. Now, if I square -5 over 2, I'm going to have a positive 25 over 4. 5 times 5 is 25. 2 times 2 is 4. So I add 25 over 4 on the right side. I have to also add 25 over 4 on the left side. And so I have x minus 5/2 squared, and then I have my plus 4, and that all equals f of x plus 25 over 4. So I get f of x all alone by minusing 25 over 4. So f of x equals x minus 5/2 squared. Now I'm going to add 4 and -25 over 4. I get a common denominator. I get 16 over 4 minus 25 over 4. That gives me -9 over 4. Okay, so we're going to have the vertex. Remember, it does the opposite inside the parentheses, so it's going to go in the positive direction, 5 over 2, and down -9 over 4. So sometimes we get a fraction for our vertex. It's not a super nice number, but we can do it. It's okay. Number 5 is harder because we have a 4 here. But if you look, 4 divides evenly into all of the pieces. So we are just going to factor out a 4 out of this equation. I have x squared minus 2x plus 3. Now we're going to do the same thing. We're going to just kind of ignore this 4 for a minute and pretend that this is all we have in this equation. So we pull out the 4. We have x squared minus 2x plus a blank to complete the square, and then I just move over my plus 3. I'm going to take this middle number and I cut it in half, x minus 1 squared, and if I take -1 times -1, that gives me a positive 1 here. And I'm going to bring down my plus 3, but all of this is times by a 4. Now I added a 1 here, but because I have this 4 right here, it's on this side. If I distribute this 4 through all of these pieces, I'm really not adding a 1. I'm really adding a 4 to this side. So on the left side, I'm also going to add a 4. so let's simplify on the right side. We're going to take that 4 and just kind of distribute it in. We have the 4x minus 1 squared plus 4 times 3 is 12. And then we're going to minus the 4 to both sides of the equal sign. And we are going to have a positive 1 and a positive 8 as our vertex. Number 6, we have a number here as well. We're going to pull out, divide a 5 to each of the pieces. Pull the 5 out. Now, this one's kind of tricky because this 3, it's not evenly divided by 5. So before I do anything else, what I'm going to do is I'm going to minus the 3 from both sides. And then it will be easy to just pull a 5 out of this other part. So I'll have x squared minus 4, and then I'm going to add a number for x. And then I'm going to add a number in so that I can complete the square. So first I cut the negative 4 in half. And then if I have a negative 2 times a negative 2, that gives me a positive 4 here. So I'm adding 4 on the right, but I'm really adding 20. 5 times 4 is 20. So I'm adding 20 to this side. So I also need to add 20 to the left side as well. So I'm going to have f of x plus 17 equals 5 times x minus 2 squared. And then I'm going to minus 17 to both sides. So my function will be f of x equals 5 x minus 2 squared minus 17. And so my actual vertex will be positive 2, negative 17. On number 3, a 3 will divide evenly out of all of these. It might be helpful to just minus 9 in the first place. It might be a little bit easier, but you don't have to on this one. I'm going to pull out a negative 3. I will have x squared minus 2x. Now I need to complete the square, so I'm going to take my binomial here. I need to figure out what I add here. If I take x or the negative 2 and cut it in half, my number is going to be x minus 1 squared, and negative 1 times negative 1, if I have x minus 1 times x minus 1, I'm going to get a negative 1 times negative 1 is a positive 1 here. So I'm going to add in a positive 1. But really, I have this negative 3 here. So I have negative 3 times 1 is negative 3. So I'm adding a negative 3 on this side. So I have to minus 3 on this side as well. So I'm going to have f of x minus 12 equals negative 3 times x minus 1 squared. I'm going to now add 12 to both sides of the equal sign. And I get f of x equals negative 3 times x minus 1 squared plus 12. So my vertex will be, I have a negative 1 here, that shifts it to the right one, and a positive 12 makes it go up 12. So 112 would be my vertex. Our method 2 is we're using the line of symmetry to find the vertex. So if I have my parabola, I can find this point right here is right on top of the y-axis. So it's going to be at -7. If I put a 0 in here and here, I will always get that that last number, that C number, as my point. So there has to be a symmetric point to this. So what we're going to do is we're going to plug a -7 in for our y. I'm going to add 7 to both sides, and when I do that, these ones cancel out. So 0 equals x squared plus 6x. I'm going to pull out an x from both of these pieces, and I have x plus 6. And so then I'm going to have, we're going to have where x is 0 and x plus 6 equals 0. So I'm -6 from both sides, and x equals -6. So I'm going to have a point at 0, 7. Sorry, 0, -7. When the x is 0, we're also going to have one at if I put a -7 in, I will have the point -6, -7, and the point 0, -7. The axis of symmetry is going to be right in the center. So if I add up the -6 and the 0, I get -6. Divide it by 2, I get -3. So the axis of symmetry is going to be right at -3. So our vertex, we have a -3 for the x. To get the y, we're going to take that -3 and plug it into the equation. So I'm going to have my -3 squared plus 6 times -3 minus 7. That's 9 minus 18 minus 7. That gives us a -16. And so that would be the vertex there. Okay, we're going to do the same thing. If I put a 0 in for the x's, I have a y-intercept at 7. So what I'm going to do is I'm going to get another y. I'm going to find a symmetric point by putting a 7 in for the y value. 7 equals 2x squared minus 6x plus 7. I minus 7 from both sides, and I get 0 equals 2x squared minus 6x. They both have an x in common, a 2 and an x, so I factor that out. And I set both pieces equal to 0. So 2x equals 0, and x minus 3 equals 0. And so x is going to equal 0, and x is going to equal positive 3. So if I have 0 and 3 as my my point where x is 7, sorry, I should move this up to 0, 7. And then I have at 3, 7. Those are my my symmetric points. At 1.5, I would have a vertex. To get the other one, I would plug it into my calculator. And that gives me 2.5. So I'm going to have the point 1.5, 2.5 as my vertex. Now method 3, we're going to be using a formula to find the vertex. So I have, this is to find my x, I use the equation -b divided by 2a. And then once I get my x value, I just plug that into the function to find the y value. So first we're going to write down our a, our b, and our c. A is 2, b is 4, and c is -7. So it's ax squared plus bx plus c. And so to find the x value, you just take -b divided by 2 times a. Our b is 4, so -b would be -4 divided by 2 times our a is 2. That equals negative 4 divided by 4 is negative 1. To find our y value, we're going to take negative 1 and plug it into the equation. So I'm going to take 2 times negative 1 squared plus 4 times negative 1 minus 7. This gives us 2 minus 4 minus 7. That gives us negative 9. So I have negative 1, negative 9. For number 11, we're going to write down our a, b, and c. Our a is negative 3. Our b is, if there's not a number, it's a 1. And our c is 5. So I'm going to take my, to find my x, I take negative b. b is 1, so negative 1 divided by 2 times my a is negative 3. This is negative 1 divided by negative 6 is a positive 1/6. When I put that into my calculator, I get 61 over 12, which is our y coordinate of the vertex.